ចាជំរាបសួរនាងខ្ញុំសូមណែនាំបន្តទៅមេរៀនរបស់យើងបន្តទៀតចាអញ្ចឹងយើងនឹងបន្តនៅមេរៀនទី2របស់យើងគឺវ៉ាឡង់និងសម្ព័ន្ធចាអញ្ចឹងនៅក្នុងមាតិកាបន្តដែលយើងនឹងធ្វើការសិក្សានៅពេលនេះគឺមានសម្ព័ន្ធកូវ៉ាឡង់និងសម្ព័ន្ធលោហៈចាគោលបំណងនៃការសិក្សាគឺចង់ឲ្យអ្នកទាំងអស់គ្នាអាចធ្វើការបែងចែករវាងសម្ព័ន្ធលោហៈនិងសម្ព័ន្ធអលោហៈទី2គឺអាចពន្យល់ពីប្រភេទផ្សេងៗនៃសម្ព័ន្ធកូវ៉ាឡង់ហើយនឹងការបង្កើតរបស់ពួកគេចាហើយក៏ចង់ឲ្យពន្យល់ពីកម្លាំងទំនាញរវាងអាតូមនៅក្នុងសម្ព័ន្ធលោហៈផងដែរចាអញ្ចឹងនៅក្នុងនេះដែរគឺយើងនឹងបន្តទៅសម្ព័ន្ធកូវ៉ាឡង់ចាតើសម្ព័ន្ធកូវ៉ាឡង់គឺជាអ្វីអញ្ចឹងនៅក្នុងសម្ព័ន្ធកូវ៉ាឡង់គឺជាសម្ព័ន្ធដែលបានពីការដាក់អេឡិចត្រូងរួមនៃម៉ូលេគុលចាអញ្ចឹងនៅក្នុងការដាក់នៃអេឡិចត្រូងរួមតើមានការដាក់យ៉ាងដូចម្ដេចថាមានចំនួនអាតូមក្លូចំនួន2នៅពេលនេះគឺវាមានការដាក់រួមគ្នានៅអេឡិចត្រូងស្រទាប់ក្រៅចាអញ្ចឹងយើងមើលទៅថាការដាក់ហ្នឹងគឺដាក់មួយម្នាក់ដើម្បីធ្វើម៉េចឲ្យអេឡិចត្រូងនៃស្រទាប់ក្រៅរបស់វានឹងមាន8អេឡិចត្រូងស្មើហើយស្របតាមច្បាប់របស់អុកតាចាអញ្ចឹងសូមណែនាំពីលក្ខណៈផ្សេងៗនៃសម្ព័ន្ធកូវ៉ាឡង់ចាសម្ព័ន្ធកូវ៉ាឡង់គឺជាសម្ព័ន្ធដែលកើតឡើងពីអលោហៈដែលការដាក់នៃអលោហៈគឺដាក់ទៅតាមអេឡិចត្រូអវិជ្ជមានដែលមានភាពស្រដៀងគ្នារបស់វាហើយវាត្រូវបានបង្កើតឡើងដោយការដាក់នៅអេឡិចត្រូងរួមរបស់វាដើម្បីឲ្យសមាសធាតុឬក៏ធាតុរបស់វាមានលំនឹងហើយពពួកសម្ព័ន្ធកូវ៉ាឡង់នេះដែរគឺវាមិនចម្លងចរន្តអគ្គិសនីទេចានេះគឺជាឧទាហរណ៍នៃម៉ូលេគុលដែលមានការដាក់នៅអេឡិចត្រូងរួមនៃអាតូម2ចាអញ្ចឹងខាងក្រោមគឺជាឧទាហរណ៍ដូចជាម៉ូលេគុលអ៊ីដ្រូសែនអុកស៊ីសែនអាហ្សូតហ្លុយអូប្រូមូនិងអ៊ីយ៉ូតចាអញ្ចឹងយើងមើលទៅលើការដាក់នៃអេឡិចត្រូងរួមរបស់អាតូមនៃម៉ូលេគុលនីមួយៗដូចខាងក្រោមដែលមានរូបភាពបង្ហាញចាអញ្ចឹងប្រភេទសម្ព័ន្ធកូវ៉ាឡង់នៅក្នុងអ៊ីយ៉ុងប៉ូលីអាតូមហើយនិងអាតូមផ្សេងៗគឺយើងឃើញថាវាជាប្រភេទនៃសម្ព័ន្ធកូវ៉ាឡង់អញ្ចឹងនៅក្នុងតារាងខាងក្រោមគឺជាតារាងបង្ហាញអំពីសមាសធាតុដែលមានអ៊ីយ៉ុងប៉ូលីអាតូមចាអញ្ចឹងសមាសធាតុនៅក្នុងតារាងនេះគឺជាធាតុទូទៅដែលអ្នកទាំងអស់គ្នាឃើញចាអញ្ចឹងនៅក្នុងសម្ព័ន្ធកូវ៉ាឡង់នេះផងដែរថាតើសម្ព័ន្ធកូវ៉ាឡង់មានការចងយ៉ាងដូចម្ដេចអញ្ចឹងសូមទស្សនានៅវីដេអូខាងក្រោមដូចតទៅ
Covalent bonds. In this video, you are going to learn about covalent bonds, how they are made, and how they form. If you haven't seen it already, first have a look at our video, Structure and Bonding. Only the noble gases exist naturally as single atoms. All the other elements of the periodic table have partially filled valence shells or outer electron shells. Atoms bond by swapping or sharing electrons in their outer shells. When very different atoms react, like metals and nonmetals, they normally swap electrons. This is ionic bonding. But when similar atoms react, like nonmetals combining with other nonmetals, they share electrons. This is covalent bonding. Nonmetals are found on the right-hand side and upper part of the periodic table. Some common nonmetals are carbon, nitrogen, oxygen, and the halides. They have shells of electrons that are normally half or more than half full of electrons. Since they have a strong attraction for a few additional electrons, it is energetically unfavourable for them to lose electrons, so they share electrons by overlapping orbitals. This makes a bonding orbital or covalent bond that contains 2 electrons. If there is space in the outer shell, a non-metal atom can form double or triple bonds, like in oxygen or nitrogen. In the displayed formula of a compound, we represent a covalent bond with a straight line, like this. We can also represent a covalent bond as a dot and cross diagram. These diagrams show only the valence electrons. To learn more about dot and cross diagrams, watch our video on dot and cross diagrams. Covalent bonds are directional, which means they are in a fixed position, like holding hands. This is different from ionic bonds, which are formed with an electrostatic attraction between charged ions. The overlap between orbitals means that the atoms in covalent bonds are very close. These things make covalent bonds strong. There are two kinds of covalent structure: small molecules, like water, and giant compounds, like diamond. Because the electrons in the bonds are evenly shared, bonds are not polarized. There is little attraction between molecules, and forces between molecules are weak. Compounds made from small covalent molecules have low melting and boiling points, and are volatile. They also don't conduct electricity. Carbon and silicon tend to form giant covalent compounds. These bond in the same way, but instead of forming small molecules with one or two bonds, they form four, making up huge lattices or chains of many, many linked-up atoms, the basis of the organic chemistry of carbon or the chemistry of rocks. One common example is diamond, which is made of carbon. Each carbon atom forms 4 covalent bonds because it has 4 electrons in its outer shell to share and has space for 4 more. If every carbon atom forms 4 bonds with 4 other carbon atoms, and each of these forms 4 bonds with 4 other carbon atoms, and each of these forms 4 bonds, we very quickly end up with a very large structure. These compounds have very high melting and boiling points because you have to break covalent bonds rather than intermolecular forces to make them free enough to act as liquids or gases. The covalent bonds hold them rigidly in place in the giant lattice. Allotropes of nonmetals bond covalently. Allotropes are different structures of the same element. You can learn more about these in our video, Allotropes of Nonmetals. So to finish, here is a challenge for you. Which of these compounds are covalent? Pause the video for a moment whilst you think. Have you considered their physical properties and where the elements come from on the periodic table? Solved it? Okay. The answer is all of these compounds are covalent. Carbon dioxide, carbon monoxide, and methanol are all small molecules. Organic molecules form covalent bonds between hydrogen and carbon. C70 is a fullerene, a carbon molecule shaped like a rugby ball, closely related to the Buckminster fullerene. Silicon dioxide is a giant covalent structure and just like diamond, but has oxygen atoms bridging between 4 coordinate silicon atoms. Hopefully, you now feel confident identifying covalent compounds and recognizing their properties.
ចា៎ក្រោយពីការទស្សនានៅវីដេអូអ្នកទាំងអស់គ្នាបានស្គាល់ហើយថាតើការចងឬក៏ការបង្កើតនៃសម្ព័ន្ធកូវ៉ាឡង់បង្កើតយ៉ាងដូចម្តេចអញ្ចឹងយើងនឹងបន្តទៅលើប្រភេទនៃសម្ព័ន្ធកូវ៉ាឡង់ចា៎អញ្ចឹងប្រភេទនៃសម្ព័ន្ធកូវ៉ាឡង់មានការបែងចែកដូចតទៅទី1នោះគឺសម្ព័ន្ធកូវ៉ាឡង់មិនប៉ូឡែរអញ្ចឹងចំពោះសម្ព័ន្ធកូវ៉ាឡង់មិនប៉ូឡែរគឺនៅពេលដែលអេឡិចត្រុងដាក់រួមគ្នានៃធាតុដូចគ្នាចា៎ឧទាហរណ៍ដូចជាអ៊ីដ្រូសែនឬក៏ក្លូរួជាដើមចា៎អញ្ចឹងនៅក្នុងរូបខាងក្រោមគឺជាម៉ូលេគុលអុកស៊ីសែនដែលបង្ហាញអំពីការដាក់រួមគ្នានៃម៉ូលេគុលអុកស៊ីសែនដែលជាប្រភេទនៃសម្ព័ន្ធកូវ៉ាឡង់មិនប៉ូឡែរចា៎បន្តមកទៀតគឺនាងខ្ញុំនឹងបង្ហាញទៅកាន់ សម្ព័ន្ធ Covalent Polar អញ្ចឹងថាតើសម្ព័ន្ធ Covalent Polar ខុសពីសម្ព័ន្ធ Covalent មិន Polar យ៉ាងដូចម្តេចអញ្ចឹងសូមមើលទៅរូបភាពដូចតទៅចា៎ចំពោះសម្ព័ន្ធ Covalent Polar គឺមានការភ្ជាប់នៅធាតុខុសគ្នាពីរផ្សេងគ្នាប៉ុន្តែវាដាក់នៅអេឡិចត្រូនរួមគ្នាចា៎អញ្ចឹងឧទាហរណ៍ទៅលើ molecule ទឹករបស់យើងចា៎អញ្ចឹង molecule ទឹកគឺបង្កើតឡើងពីអាតូមពីរផ្សេងគ្នាគឺអាតូមអ៊ីដ្រូសែននិងអាតូមអុកស៊ីសែនហើយអាតូមខុសគ្នានេះដែរគឺវាដាក់នៅអេឡិចត្រូនរួមគ្នាចា៎ដូចបានរៀបរាប់ខាងលើអញ្ចឹងអ្នកគ្រូសូមសួរថាតើសម្ព័ន្ធ Covalent គឺជាអ្វីហើយមានការបែងចែកនៅប្រភេទយ៉ាងដូចម្តេចខ្លះចាអញ្ចឹងនាងខ្ញុំសូមបន្តទៅសម្ព័ន្ធលោហៈចាអញ្ចឹងថាតើសម្ព័ន្ធលោហៈគឺជាអ្វីចាសម្ព័ន្ធលោហៈគឺជាសម្ព័ន្ធដែលត្រូវបានបង្កើតឡើងពីលោហៈពីរផ្សេងគ្នាហើយមានការភ្ជាប់គ្នាយ៉ាងរឹងមាំចាជាលក្ខណៈនៃសម្ព័ន្ធលោហៈមានយ៉ាងម៉េចខ្លះទៅនៅក្នុងលក្ខណៈនៃសម្ព័ន្ធលោហៈគឺវាត្រូវបានបង្កើតឡើងរវាងអាតូមលោហៈនៃធាតុ2ដែលអេឡិចត្រូនរបស់វារត់ជុំវិញអាតូមហើយវាមានលក្ខណៈចម្លងចរន្តអគ្គិសនីបានល្អនិងមានពន្លឺចែងចាំងហើយមានចំណុចរំពុះខ្ពស់ផងដែរចា៎ឧទាហរណ៍ដូចជាសូយ៉ូមដែកអាលូមីញ៉ូមមាសហើយនិងកូបាល់ចា៎
Metals are used in many everyday objects. This morning, when I woke up, I decided to have a soft-boiled egg and a cup of coffee. The pot I used is made of metal. The kettle is made of plastic, but the coiled heating element inside it is made of metal. Metals are good conductors of heat. This is the reason why metals are used to make these everyday objects. You would never see a pot made of wood or a heating element made of plastic. Metals are also good conductors of electricity. The wire connecting your kettle to the electrical socket is actually made of many copper wires, insulated with a layer of rubber. Think about the shapes of the everyday objects we described. The pot, the heating element inside the kettle, and the copper wires. Notice that they are very different. Metals are malleable. This means that they can be molded into different shapes. Metals are very ductile. This means that they can be stretched into wires. To fully understand these properties of metals, we must understand metallic bonding. When we talk about metallic bonding, we are actually describing the electrostatic attraction between the metal ions arranged in a lattice structure and the free-floating electrons around them. Since these electrons are free to move around, the term sea of electrons is also used. What is a lattice structure, and where have you heard this term before? Let's pause the lesson to think about this and resume when you are done. The term lattice structure means that there is a regular repeating pattern. We have heard this term before when discussing ionic lattices. It is used to describe the alternating positions of the metal and nonmetal ions. In metallic structures, however, there are only metal ions. These metal ions are arranged side by side in a regular repeating pattern. The free-floating electrons act like a glue and hold the structure in place. This is a very strong attraction and explains why metals have high melting and boiling points. A lot of heat energy is needed to overcome this attraction. This is also why metals are very good conductors of heat. Free-floating electrons are the reason why metals can conduct electricity. Metals are malleable and ductile because no matter what shape the metal takes, the free-floating electrons will conform to that shape. The strong electrostatic attraction will remain, and therefore the structure stays intact. Let's think about it. Cars and bicycles, trains, planes, buildings, cutlery, spectacles, furniture, and endless items can be made from metals. To recap, the electrostatic attraction between metal ions arranged in a lattice structure and free-floating electrons is known as metallic bonding. This explains many properties of metals. They are good conductors of heat and electricity, have high melting and boiling points, and are malleable and ductile.
Chà, អញ្ចឹងមេរៀនរបស់យើងគឺត្រូវបានបញ្ចប់ត្រឹមនេះសូមបន្តទៅលើការអនុវត្តទៅលើការធ្វើលំហាត់ធ្វើតេស្តទៅលើការយល់ដឹងសមត្ថភាពយល់ដឹងរបស់អ្នកទាំងអស់គ្នាចាលំហាត់អនុវត្តតើរូបគំនៃឧស្ម័នកម្រអ្វីត្រូវបានបង្កើតនៅពេលដែលអាតូមនីមួយៗនៃលោហៈបោះបង់នៅអេឡិចត្រុងរបស់វាអញ្ចឹងចូលសរសេរនិមិត្តសញ្ញាសម្រាប់អ៊ីយ៉ុងនៃលោហៈដែលវានឹងបង្កើតចា៎ A potassium B magnesium C aluminium D barium ចា៎នេះគឺជាចម្លើយរបស់វា A potassium គឺវាបង្កើតលោហៈ argon ដែលបង្កើតបន្ទុក potassium បូក B ឧស្ម័នដែលវាបង្កើតគឺ argon ហើយបង្កើតបានជាបន្ទុក magnesium 2បូក C បង្កើតបានជាឧស្ម័ន neon ដែលបង្កើតនៅបន្ទុក aluminium 3បូក D បង្កើតឧស្ម័ន xenon ដែលមានបន្ទុក barium 2បូក ចា៎អញ្ចឹងលំហាត់គំរូបង្ហាញត្រឹមតែប៉ុណ្នេះហើយមេរៀនរបស់យើងក៏ត្រូវបានបញ្ចប់ត្រឹមប៉ុណ្នេះដែរអញ្ចឹងសូមអ្នកទាំងអស់គ្នាធ្វើលំហាត់អនុវត្តបន្តនៅក្នុងមេរៀនផ្នែកខាងក្រោយរបស់យើងដោយមានភ្ជាប់នៅ answer key ជាមួយផងដែរចា៎សូមអរគុណ